Hi guys, today is our class 4. We will be talking in details about entity relationship diagrams and entity relationship model. Um, that's first part of the class. Second part of the class, we're gonna do a little practice exercises and we will create simple models and we will learn how to read entity relationship diagrams. Also, some of them are simple, some of them are a little more complicated, but in the first part of the lecture, we're gonna learn about entity relationship models and all the components. So let's start. Um, let's talk a little bit about first homework. So first homework is posted, and I hope some of you already start working on that. So according to the plan, it's supposed to be done with homework one, question one, and question two. And I hope you are on track. So a little bit about homework again, it's 100 points. Do not collaborate with other students. It is an individual assignment. Make sure to proceed with it as such. I do not accept two homeworks that look exactly the same or somewhat similar. So it is an individual assignment. It is posted, as you know, in assignments. Deadline is in 2 weeks. Please check Canvas. I am available to help you. If you have questions or you need help, please reach out. I will be happy to work with you. Please plan to submit a couple of hours before the deadline because there are multiple issues. I've heard about powder outage, the big file, laptop broke, and so forth. So make sure that you allow yourself a little bit of time to submit this assignment. Just a reminder that all the diagrams must be created using tool. Hopefully you completed the assignment and you selected the tool that you'll be using for diagrams. If not, please do so. It is a prerequisite for this lecture, and make sure that you use a diagram for the tool and no handwritten diagrams. Okay. All right, so have any questions about homework one, please reach out. I'll be happy to clarify it for you if you have any questions. So let's start with our topic. So last class, it's a review of the last class. Last class we talked about different data models. We talked that data models are a communication tool. We also talked about the importance of data models as a first step of the actual database creation. We looked at data models from the abstraction point of view. We talked about data abstraction, what it means. And data abstraction, if you remember, is a simplification of real life objects to simplify a concept. So abstraction is an ability to present the functionality without getting into too many details. We talked about different data models. We talked about external, conceptual, internal, and physical data models. Talked about logical and physical independence. Those are the two very important concepts that we will be dealing with a lot in this class. We also looked at business rules. We discussed what is business rules. We looked at the examples of different business rules. And also we looked at in details in relational data model. And we know that relational data model in the basis of it has a relations or table. We looked at table primary keys, foreign keys. We also looked at the example how to connect tables together. And the rest of the class, we spent discussing entity relationship model. So we talked about entities, attributes, relationships, and we also learned how to read a very basic model. That's what we did last class. Today, we will be learning entity relationship model in details. We're gonna look at the main characteristics of the models. We're gonna look at details of all the components that belongs to entity relationship models, and those are entities, attributes, and relationships. We're gonna look at relationship entity types and instances. We're going to look at relationship types and instances. We're gonna also look at different types of relationships. So we're gonna look at cardinalities, relationship degrees, which is large part of the homework one. And at the end, we will learn how to read and create entity relationship diagrams. So that's what we'll be doing today. Um, So that's a little review from the last lecture too. So entity relationship model is a conceptual data model, as we remember. It's used to describe how database design is going to be. We also know that it's a very high level of abstraction. What does it mean for us? It means that a lot of details are not going to be part of this model. So later on, when we'll be working further on logical design, we will create a better model that will allow us to create the database. But right now, we still are at a very high level of abstraction. So entity relationship model is a basis for anti-relationship diagram is a basis for anti-relationship models. We're going to be creating anti-relationship diagrams today. And here we have the main entity relationship diagram components. Those are entities, attributes, relationships, and constraints. So let's start from entities. Entity is an object of our interest. It's something that we're trying to model. So it can be place, event, concept, anything that we are trying to introduce with this model. So it can be employer, student, can be warehouse, can be machine, building, events, concept, account. So anything that we're trying to model is an entity. Um, so there's two very interesting concepts. So first one is entity type. Entity type is a group of entities that have the same common properties or characteristics. And entity instance is a single occurrence of an entity type. If you think about the database, it's a row in the table. So let's look at the example. Here's an example of employee entity with two instances. So employee entity is has various attributes. There's total of 8 attributes here: employee number, name, address, city, state, zip, date, and date hired, and date of birth. All of them have different data types. We're going to talk about data types more in details later on, but just for now, think about character. It's a string field, so it's just a list of characters that build probably words together, and date is a date. Instances, employee instances are here. So employee instances are pretty much data that belongs to two different employees. So in this example, we have Michelle and David, and we have their employee numbers, their addresses, and the dates. So that's example of entity types and type and entity instances. Again, when we talk about the tables, entity instance is a row in a table. Okay. So you will be defining entities in your team project. So here's a couple of guidelines for you guys to use when you will be defining entities. So entity can be an object that have many instances in the database. an object that has multiple attributes. So entity must have multiple attributes. An object that it's also an object that we're trying to create a model, right? And that's what we discussed a couple of slides ago. Um, what entity shouldn't be is a user of the database or an output of the database, something that we're trying to retrieve from the database. What do you guys think about it? Why user and report shouldn't be entities? And I'm going to give you a little hint. Um, user is part of the external data model. So put a pause here, think about it a little bit, and see if you can answer it. All right. So the reason why we can't use user cannot be part of ERD or our or entity, it can be part of our conceptual data model, is because user is you can see here that user lives in the external data model. So you can see, and we are currently trying to model conceptual. We are trying to create a designer's view of the database. So we are in the level of conceptual data model. So that's why user has a higher level, lower level, higher level of abstraction than our current model. That's why user is not part of the conceptual data model. So a couple of guidelines for team project for entity definitions. So the way you define entities, a good example is for an X is. So, for example, a student is a person who takes classes in the university. A concert is an event that is attended by different multiple people. Here's another couple of examples here. So we also need to make sure that we described every unique characteristics of each instance. So, for example, an expense is a payment for purchase of some goods or services. An expense is identified by a journal entry number. So, those two definitions tells you what actual expense is. So they tell you that when we're purchasing some goods, we have a payment, and this payment is an expense. And down here, we also have another example. So the expense uh, is identified by journal entry. A journal entry number. That means that journal entry number is an attribute of the expense, and it's also an identifier of this expense. Um, in a lot of cases, we need to provide information not only on what entity is, but also and what entity is not. So, for example, here we have customer is a person that place an order, but customer does not include people that buy products through other from the same company through the agents. So we know what customer is, and we also know what customer is not. Um, in some cases, it's important for the business model to know when the instance of the entity is created or destroyed. So, for example, customer stop being a customer if they didn't place any orders within the last 3 years. So that's important. Let's look at this example. So here we have four entities, and I want you to practice what we learned during the previous couple of slides. So I want you to identify what are correct entities and what are wrong entities. And remember, we talked about that in the past. So user and report are not part of the conceptual data model. So look at three entities here and try to think what can be a good entity and what is not. All right, so treasure is a system user. And again, like system users are probably not are not part of conceptual data models, so it's their own entity. Report also is a system output, so it's not a good entity, and the other two, account and expense, are good entities. Uh, Explanation for that, expense report is something that we retrieve from the system, and that's why it's not part of our model, and treasure is the user. It leaves treasure using our system, so he lives on external data model. Here's another example for you guys to practice. So please pause and look at this example, and I'll give an explanation in a few minutes. Right, so here, same idea. Admin is type of system users. User is also type of system user. So those two are not good entities because they live in external model, and the rest of them are good entities. Let's try another example. So let's look at this scenario, and let's try to identify what can be potential entities for entity relationship diagram. Um, we have a music store, and each user is associated with one or more accounts. Accounts are mechanisms through which user purchase songs through the store. For each accounts, multiple usage reports are generated, documenting songs and their usage frequencies. New accounts do not initially have usage report. However, during their first months of existence, reflecting a dynamic functionality of system. So let's look a little bit in this scenario. I'm going to give you guys a couple of minutes, and then I'll explain you what can be an entity and what cannot be an entity. All right, so, oh, what's happened? Where was it? All right, back in business. Hmm, what just happened? Sorry about that, guys. Let me bring the presentation back. Mhm. Technical difficulties. My laptop is upgrading. Decided to upgrade the moment I was recording the lecture. All right, so let's go back to the slideshow. Right, so potential entities here is, well, we can think about music store being an entity. However, music store is mostly the system that we're trying to design. So then going further, we have a user being associated with one or more accounts. Well, user, as we remember, is part of the external data model, so user cannot be an entity. Um, so accounts is probably a good entity, right? So now we have more information about the accounts, and then we have songs. So songs is also probably a good potential entity. We don't know much details about songs yet, but it can be. And then further down, we have a lot of information about multiple usage reports, right? And the usage reports, as we remember, is also not part of the conceptual model because it is a system output. So none of those reports can be part of the conceptual model. So here we go. Good entities are accounts and songs, and user and usage reports are not potential entities. Now, we talked about what entity can be, what entity cannot be. Now, let's talk a little bit about different entity types. So we have strong entities. Strong entities can exist independently. They don't need any other entities. They don't have any links to other entities. So those are independent entities. So they have their own identifiers, right? And now let's start learning a little bit about diagrams. Identifiers and entity relationship diagrams are underlined with a single line. And here we have an example of a strong entity, which is employee. Okay, employee is a strong entity. It has three different attributes: employee ID, employee name and title, and employee ID is identifier. We're going to talk about identifiers in a little bit, but for now, just remember that identifier is unique for each entity instance, and it is underlined as an attribute. Now, we also have weak entities. Weak entities depend on strong entities. So we call those strong entities identifying owners. Weak entities cannot exist on their own. So in our example, we have an employee and we have a dependent. Dependent is can be employee family members. So since employee work in the company, all the dependents, they get some kind of benefits through this employee. So if the employee wouldn't exist, we wouldn't have dependents for this employee. So weak entity depends on strong entities identifier, cannot exist on its own. Weak entities also do not have a unique identifier. They have only a partial identifier, okay? So in this case, employee ID is a partial identifier. And here also entity box and partial identifiers have double lines. I'm not going to enforce that for you guys, so you can use double lines, you can use single lines. So for now, I guess it's not that important. So just remember that weak entities cannot exist without strong entities. So they depend on strong entities. And relationship between strong entity and weak entity called identifying relationships. That's a link between strong entity and weak entity. Okay, so strong entities, weak entities, identifying relationships. Okay, so let's look at the example. Let's identify what are strong entities, weak entities, and identifying relationship. I'm gonna give you guys a little bit of time, so pause the video here, try to answer the question, and I'll explain in a few minutes. All right, so in this example, we have two strong entities, student and class. They can exist independently from other entities, and we also have a registration entity, which is a weak entity. It depends on both class and student, and the relationship between class and registration and student are identifying relationships. Okay, so here's that. Now, we talked about in details about entities, we talk about entity types, instances. So the next important concept for entity relationship diagram are attributes. So let's talk a little bit about definition and naming convention. Attribute, as we talked a lot before, is a property or characteristics of the entity or a relationship type. We're going to talk about relationship attributes in a little bit. So, couple of examples, student entity attributes, student ID, name, student address, phone number, major, all of those are student student entity attributes. Have a typo here, student. Automobile entity has some attributes, employee entity has some attributes, and so forth. So, attribute characteristic of an entity. There's a couple of naming conventions or a couple of rules that I suggest you guys to use when you will be identifying attributes for your team project. So attribute, the rule of thumb, it should be a single noun or noun phrase. Attributes are unique, so one entity cannot have two exactly the same attributes. And it's a very good idea to follow the naming convention standards. So when you identify an attribute, it's good to have an entity name followed by an attribute name. So in this case, student is name of the entity. So student name is going to be a name of the attribute and so forth. Again, I'm not going to cut down points from you guys if you don't name them correctly, but a good naming convention is going to help you in the future when you'll be creating tables. So it's important to define naming convention for a project and follow it. Okay. So that student entities, those are student attributes. There's various classifications of attributes, and we're gonna look at three of those in details, and then we're gonna look separately at identifier. So let's start from required or versus optional attributes. So each entity or table in the future will have various attributes. So required attribute is an attribute that must have a value. So it must have, it cannot be null, it cannot be empty. Okay, so it always must have a value. Optional attribute can be empty or null. So it doesn't have to have a value. It can have a value, but it's not required. Okay. So required attribute must have values. Optional can be null, can be empty too. So here's an example of required or optional for attributes for student entity for two student entity instances. And as we can see that student entity has one, two, three, four, six, seven required attributes, and one attribute is optional, major. So maybe some student didn't select a major yet. In this case, Melissa didn't select her major yet. So attributes can be simple and composite. Simple attribute have only one attribute as part of it, so cannot be divided into smaller components. Composite attributes and an attribute that has multiple parts or sub attributes. So think of a concept that needs a lot of smaller details, but it's still a big, larger concept. So, for example, employee address consists of uh, street address, city, state, and postal code. So in this case, composite attribute is employee address. And in parentheses, we have list of simple attributes that are part of the composite attribute. And here's an example for a student entity. We have a bunch of simple attributes: student ID, student name, registration, date of birth, so forth. So single, it's one property composite one property that consists of multiple properties or sub attributes. The way composite attributes defined in the diagrams, we define the main attribute. In this case, it's employee address, and then we list simple attributes in parentheses that are components of this composite attribute. Let's look at the example. So let's try to identify student entity attributes for this scenario. University maintains a database of its students. For each student, university tracks key information such as student ID, enrollment date, personal details like student's name, and emergency contact information. Let's stop here for a second. I'm going to let you guys think a little bit about it. Please pause the video, and in a bit, I'm going to explain the answer, and we're going to look at that together. All right. So here's what I have. So we talked about students. So university tracks key information such as student ID, enrollment date, and those are simple attributes, right? Student ID and enrollment date. Now, we also have a personal details like student first name and emergency contact. So in this case, student name I put as a composite attribute because it has first name and last name. Emergency contact, I added simple attributes as part of the emergency contact, but emergency contact, it's clear that it needs multiple simple attributes. Okay. So here's an example that has both simple and composite attributes. And again, like, I mean, here, that is my design. I thought through that, and I think that student name must be first and last name. But again, you can have those as a separate attributes, first name and last name. And instead of having student name as a composite attribute and first and last name are part of this composite attribute. Single valued and multi-valued attributes. So single value holds only one value for a certain instance. For example, student ID, for example, employee ID, name, address, date of birth, phone number, those are hold only one value, right? One employee cannot have multiple first names, say. One employee can potentially have multiple addresses, but usually when someone is getting to a job, like we only hold one address of this employee. And there's also multi-valued attributes, those that can have multiple values for the same instance of an entity. So in this case, employee can have multiple skills. For example, if you're talking about software engineer, he or she or they can know Java, SQL, Python. And the way we identify multi-valued attributes, we put them in curly brackets. Multiple examples of multi-valued attributes can be skills, can be phone number, can be a multi-valued attribute. One person can have multiple phone numbers. Email address can be multi-valued attributes. So multi-valued attributes are very common. So phone number. Here's another question about phone number. So here phone number is a single valued attribute, but it can be multi-valued. Okay. Let's look at the example here. So let's try to identify single valued and multi-valued attributes. So library management manages its collection of books by storing key information for each title, including book's ID title, publication, year, and genre. A single book can belong to multiple genres. For example, book might be categorized as fiction and adventure. let's pause the video and I'm gonna let you guys think a little bit and I'm gonna explain you the solution for this example in a second. Right. So, hopefully you get the same or somewhat similar answer as I have here. So we have a book entity with book ID, title, and publication, and genre is multi-valued attribute because one book can belong to multiple genres. Okay, and book ID, I guess there's no, I mean, there's no questions about book ID. Book ID is probably identifier of the book, so it's only one per instance. Title two, year of publication can be multi-valued, right? But here's the last sentence about genre tells us that it can be multiple genres per one book, so that's why it's multi-valued. And again, we remember that we put multi-valued attributes in curly brackets. All right. Hopefully you get to something similar, some answer like this. Now, there's also a very special case, multi-valued composite attribute, price history. So attribute can not only be multi-valued composite and can be both at the same time. So in this case, we have a product with product ID and the price history. So we can have different price histories, right, per product. So we can have price can change, right? And this price history is also a composite attribute that consists of effective date and price, two simple attributes, right? So it's price for a certain date. So once we have a date and price, we know that those are part of price history composite attribute. And again, like it can be multiple different combinations of price history for a specific product. That's why it's multi-valued. So multi-valued composite attributes, here's an example. Um, let's try to identify the type of each attribute for this product entity. Um, look Look at this example for a minute and please pause the video and I'll explain later the answers. All right, so for this product entity, product ID is a simple attribute, right? So it's probably also a unique identifier of this entity. We also have a product name, which is a composite attribute that consists of brand name and variant. How do I know that? We have curly brackets. We also have component attributes in the middle. So this is composite attribute. Description is a simple attribute. Again, like only one simple attribute doesn't have any components. So it's simple. Product code similar to product name, also composite attribute, and the components attribute of product code will be category, manufacturer, serial number, category ID is simple attribute, and product features is a multi-valued attribute. How do I know? It's because it's enclosed in curly brackets. Okay. All right. So simple. Now, let's look at the very special case of attributes, identifiers. Identifier is an attribute that uniquely identifies a specific instance of the entity. It can be an attribute or a group of attributes. Can be, in our case, it can be simple or composite. And in student entity, unique identifier is a student ID, and it is underlined. Important to understand that identifier must be a required attribute, so it cannot be null. because it must uniquely identify the row, similar to primary key, which we'll talk later in this class. There's also flight, and flight has flight ID, which is composite because, as we know, it can be multiple flights with the same number over the multiple days. So flight ID is a identifier that consists of two component attributes, flight number and date. Okay. Um, well, there is also such a concept as candidate identifier. It is an attribute that could be identifier, but it satisfies all the requirements of identifier, but it was not selected as identifier because probably there's some better identifier exist. Okay, so now couple of criteria for identifiers, very important for a team project. So, how do we choose identifiers? How do we know what specific attribute is an identifier? So we choose the attributes that are unique. We choose the attributes that do not change values. We also choose the attributes that will never have a null value. Important to avoid so-called intelligent identifiers. Those are identifiers that contain location of the people that might change often, so geolocation, stuff like this. And it's also a good idea to substitute long identifiers that are composite for simple. So, for example, say we have a client entity, and what uniquely identifies a client is a combination of the first name, last name, date of birth, and age. Because again, people can have many people can have the same first name, last name, and date of birth, but or a combination of first name, last name, and date of birth and age will probably be a unique for each person. But there is a lot of attributes to put as an identifier. So in this case, we um, replace it with a client ID, which is a simple identifier. Okay. Um, let's look at this example. Let's see what can be a unique identifier of the student entity or student table. I'm gonna put a pause for a second and I will explain you in a bit. All right. So in this case, we have various attributes that can be potentially used as identifiers, right? Student ID is probably best identifier because it's short and it's simple and it's unique, again, for this data set. So most likely it's going to be a unique identifier. Now, we also have a social security, right? But it's somewhat long and well, as we know, Social Security is not a good practice to use. So instead, we use student ID as identifier. Now, the question is, um, can email be identifier? What do you guys think? Can it be identifier? Well, um, yes, it can, but in theory. However, for this specific example, it cannot be identifier because it has a null value for John. And as we remember from the previous slide, identifiers cannot have null values. Okay. Um, so let's look at the examples and um, see what are good and what are bad identifiers in this table. So pause the video and do this as an individual exercise. I'm gonna explain in a bit. All right. Hope you have answers. So here we go. Phone number, first and last name, composite identifier, probably loan identifiers. Probably not a good idea to use. Phone numbers can change. People can change their last names. Social Security is a good example of identifier. It doesn't change. It's longer value, and we have legislation not to use it, but it does satisfy all the requirements of being identifier. Transaction date and time. We can have multiple transactions during the same date and time. Well, think Amazon as a large retailer that does a lot of sales every second. So that's not a good identifier. Customer address also is not a good identifier. It can change and it's also loan. Um, Product code SKU is a good identifier because it doesn't change. It uniquely identifies the product. So it's a good example. Same with employee ID. ISBN for books also a good identifier. VIN number for cars also unique, good identifier. And product description, again, the description can change, so it's probably not a good identifier. All right. Now, how do we define attributes? This slide is also helpful for a team project. So when we when we define the attributes and create business rules for attributes, it's very important to state what is the attributes and why it is important. So what role does it have? What value does it hold? So we need to make sure what's part of it and what's not part of this attribute, similar to entities. So for example, attribute payment method metadata. So say we have payment methods where we accept credit cards, debit cards, cash checks, but we um, do not accept specific cards. So, for example, we can accept Visa and don't accept MasterCard or American Express. We can accept both Visa and MasterCard, don't accept Express, so forth. So, again, as part of attribute definition, if applicable, we need to describe what is and what is not part of the attribute's value. So we also need to state when attribute change once we set those. So for example, say the date, update date is updated every time we make a change to a specific entity instance. So we describe the state whether attribute can be changed, can be required or optional. So we talked about required and optional attributes, and it's important to state that when you define attributes. Also state minimum and maximum number of occurrences that attribute can hold. It's Sometimes it's important. So, for example, say when we have a composited identifier, for example, for skills. So we can say that employee can, in our system, employee can have up to 7 different skills, right? Now we talked about entities, attributes. Let's talk about relationships. We already know about relationships, and relationship is something that connects to entities, right? So, it describes how those entities, the associations between two entities. Similar to entities, relationships can have types and instances. And relationship type is a general association between two entities, a line in entity-relationship diagram, and instances are specific occurrence of this relationship type between different instances of related entities. Let's look at the example. So we have in a relationship type here, which calls completes. So employee completes courses. So many employees can complete many courses. So complete is a relationship type. But also we have multiple relationship instances. So for example, we have various employees here and different courses. So say, for example, employee Chen completed C++ and Java, Melton completed C++, COBOL, and Perl, and so forth. So relationship instances are connection between association between two different entity types. Right. So let's look at the example and let's identify relationship type and relationship instances for this relational data model. So what is a relationship type? Um, so we have books table and categories table, and each book is associated with a certain category. So the relationship type probably will be a relationship between book table or entity and categories. So it can be belongs relationship or any way we want to call it. So this relationship represent a relationship between book and category. Um, how many relationship instances represented here? So let's look. So we have book 1 belongs to category 2, which is 1. Book 2 belongs to category 5, 2. Book 3 belongs to category 3. Um, Book 4 belongs to category 4 and 5 belongs to category 7. So it's total of 5 different relationship instances. I'm sorry, 4 different relationship instances because we don't show category 7 here. So it's total of 4 different relationship instances. All right. Um, so similar to entities, relationships can have attributes, and attributes describes the relationship. So attribute provides more information on certain relationships. So it doesn't belong to any related entities, but rather belongs to a specific relationship. So in this case, we have employee that completes the courses, and when employee completes the course, we have a date completed. So date completed is not part of the employee, date completed is not part of the course. Date completed, it's part of the relationship completes. Okay, so this is an example of relationship attribute. Um, let's look at the scenario. And again, the reason why we're doing those scenarios is because you'll have a lot of scenarios to review in your homework and the exams. So we're like doing a little practice here. So identify entities, relationship, and attributes on the relationship for the following scenario. So in college, students engage in a variety of extracurricular activities, sports, clubs, and so forth. These activities help personal growth. So college keep tracks of students' extracurricular activities, recording join and date. I'm gonna pause for a second and let you guys think a little bit, and then I'll explain his answer. All right. So students engage in activities. So there is students is an entity, engage is a relationship, and extracurricular activities is another entity, probably. Again, we don't have a lot of details, so we're doing a little bit of guessing here. But then last sentence tells us that students when students when students enroll in the extracurricular activity, we record join date. So entities will be student and extracurricular activity. Um, and the relationship is going to be between student entity and extracurricular activity entity, and attribute in the relationship will be joining date. Okay. All right. So there is an attribute in the relationship from our previous example, right? Employee completes the course. Um, but there's also can be this attribute in the relationship can become an entity. So this type of entity called associative entity. It's an entity, but it also has attributes. And it also a relationship. So it helps to link two entities together. So let's look at the example. So in this case, we have an employee that completes the course, but course also has a certificate. So, and we have a certificate number here. So, in addition to date completeness, we have more meaning to this date completeness attribute. We have a specific certificates given to an employee when employee completes the course. So in this case, certificate will be an associative entity. So we have a certificate number that is a unique number, and date completeness is an attribute. So now, when do we actually use relationship with attribute versus associative entity? That's a very important question because there is a specific scenario for each one of them. So we use associative entity when we have many-to-many relationships. So, for example, student register for courses, so multiple student can register for multiple courses. Instructors teach multiple departments, so we have extra instructors and departments. We also use associative entity when we have a specific meaning independent of other entities. So, for example, completion certificate. So it's not part of the student, it's not employee, it's not part of the course. It doesn't belong to any of those. It belongs to a specific place called associative entity. Ideally, associative entity must have a unique identifier and have other attributes. And there is also, and in the rest of the scenarios, we can use easily attributes and the relationships. And there's also a couple of scenarios when we can also use associative entities, but those are more advanced. So I just put them here so you guys would know. We use associative entity when this specific entity can be part of other relationships, and also to convert ternary relationship into binary. We're going to look a little bit in ternary relationship, but the ternary relationship is not going to be covered in details in this course. Okay. All right. So let's look at a couple of examples. So first example is library checkouts. So in library system, members can check out multiple books. Each book can be checked out by multiple members. We record checkout date and due date during the checkout, capturing when book was checked out and when it's due for return. I would like you to decide whether we are going to use associative entity here or attributes on the relationships. But before we do that, we need to identify entities and for this specific scenario, two entities that we're dealing with for this specific scenario. I'm going to pause for a couple of minutes, and I'll let you guys think, and I'll explain you a solution in a second. All right. So let's look at this example in details. So we have members that can check out multiple books, and book can be checked out by multiple members, right? So two entities of interest here, books and members with many-to-many relationship because it's multiple on each side. Now, we have a checkout. And checkout is a relationship, right? So during checkout, we are capturing a lot of information. So we are capturing due date, we are capturing return date. So um, in this case, we have a lot of information that we need to record. So we are going to have associative entity for checkout because it has multiple attributes. It also probably have a unique characteristic. So library keeps track of different checkouts. That means that checkout probably will have also a unique identifier further down in design. In addition to existing attributes, checkout date and due date, it will also have a unique identifier checkout ID. All right, so let's look at another example. So we also let's try to identify whether we need to use associative entity or attribute in a relationship here. Scenario, we have social media platforms, members can have multiple friends, and members can see when friends added to their profile to track the status of their friend requests. So um, let's decide what are we going to use for this scenario. So you pause the video, think what is better option, and I'll explain later. All right. So, similar to the previous example, it's also a case for associative entity because there is various attributes we need to track for this friendship. So we have two entities, members and friends, and we have a relationship between those called the friendship or whatever you can call them. It's not enough. So this scenario doesn't define the type of relationship. So I put friendship here, but you can give it any other meaningful name. And again, the attributes of this friendship relation associative entity will be date and status. So this friendship concept has a meaning to that. So that's why, and it also have attributes that we track. So that's why it is a case for associative entity. Because remember, when there is multiple various guidelines on when to use associative entities. So one of them is when we have many-to-many relationship. Another one is when we have a specific meaning to a concept or an attribute, and also when we have multiple attributes. Let's look at one more example. So same here. Let's decide whether we're going to use associative entity or attributes on a relationship. So employee can be assigned to one project at a time, and project can have up to 5 employees that work on a project at the same time. An employee is assigned a role to each project. For example, they can be project manager on one project and can be developer in another project. So think a little bit about this scenario and I'll explain. All right. So let's do a similar analysis to what we did in the previous two scenarios. So what we're looking for is whether the relationship is many to many and whether there is a meaning to a specific attribute here. So here we have an employee can be assigned to one project at a time, and project can have multiple employees. So it's one to many relationships, so it's already doesn't satisfy the first criteria where we for associative entity where we must have many to many. And also, there is not much information to that other than role. So we don't have a date of assignment, we don't have any other information, it's just a role. So this is a good scenario for attribute in a relationship. So we'll just have one-to-many relationship, and attribute in this relationship is going to be role, right? So talked about different types of relationship. Now we're going to talk about relationship cardinalities. We did touch this topic a little bit at the end of the last lecture, but now we're going to expand on that. So what is relationship cardinalities? It's a possible number of instances of one entity can be associated with the instances of another entity. So it defines the minimum or maximum number of occurrences that is related to each other in within certain relationships. So when we have only one instance of one entity related to one instance to another entity, we have one-to-one relationship. So example, one car can belong to only one manufacturer. Okay, so it's a one-to-one relationship. There's also one-to-many, when one entity can belong to many instances of another entity. And there is many-to-many, when many instances of one entity can be related to many instances of another entity. Okay. Now let's look at the cardinalities from the cardinality constraint. And cardinality constraint tells us a lot about whether can help us to decide whether relationship is mandatory or optional. So cardinality constraints is a number of instances of each entity that can be associated with each instance of another entity. So, for example, we have a basic relationship here, movie and DVD, and we can, when we know more details about those relationships, we can turn the diagram above into more complete diagram where we know exactly what data we have. So here we on the bottom diagram we have relationship with cardinality. So movie we have movies and DVDs here. So movies can be on multiple DVDs, can be stuck at multiple DVDs, but it's not required to be stuck at DVDs. So it doesn't have to be on DVD at all. So minimum cardinality on the DVD side is 0. Maximum cardinality on the DVD side is many. Minimum on movie side is 1, and maximum is 1 too. So now we have a much better, much more defined meaning for minimum and maximum cardinality. So minimum cardinality defines whether relationship is optional or mandatory. If minimum cardinality is 0, relationship is optional. If it's 1, it's mandatory. Okay. And maximum cardinality is just defines the max number of relationships that that is part of the business rules. So here, for example, DVD must contain at least one movie, and it must contain one movie because I mean DVD must be on the movie, must implement something, right? So DVD must have one movie. And as for movies, movie can be recorded on DVD, can be recorded on multiple DVDs, but it doesn't have to. So minimum cardinality is 0, so relationship is optional on DVD side. Right. So minimum cardinality defines whether relationship is optional or mandatory, and maximum cardinality defines how many relationship can it be, like one or many. Okay. So example, minimum and maximum cardinality, employee must be assigned to one project. So minimum cardinality is 1 and maximum is 1 too. So and project must have at least 2 and maximum of 6 employees. So since minimum cardinality is more than 1, relationship is mandatory, and 6 is the max number of relationship, which is implemented in diagram as crow's foot. So anything more than 1 means many on ERD, means crow's foot. Right. So let's look at cardinality constraints. So here we have an example of mandatory relationship. So patient history to patient. So minimum cardinality is 1, relationship is mandatory, max cardinality not specified. So um relationship between patient to patient history is also mandatory because minimum cardinality is 1. And maximum cardinality is here, it's not specified, but I mean, we put it as 1 here because patient history can belong only to one patient. All right, and here's an example. So patient Mark has 1 visit, so it's only history for 1 visit. Sarah has 2, and Elsie has also 1 visit. Um, Cardinality constrain optional relationships. So, for example here is it's unary relationship, and example here is like a person is um, married to one person. So, optional cardinality 0 means that the person doesn't have to be married. So, minimum cardinality is 0, relationship is maximum is optional, and max cardinality is 1. So well, it's not specified, but it's 1 here. So the person um can be married to one person again. Like I mean, this doesn't represent polygamy. If it would be polygamy, it can be changed to crow's foot on the both side. But here we have an example. Shirley is married to Alice, Meg to Kathy, and Dawn is not married, so it represents optional. All right. So let's look at another example of cardinality constraints where we have 1 mandatory and 1 optional relationship. So employee to project. So minimum cardinality is 0, max cardinality we don't have max cardinality specified, but it's many. So employee can work on multiple projects, but employee doesn't have to work on project at all because the relationship is optional. So employee doesn't have to be assigned to a project. The project to employee minimum cardinality is 1, mandatory, max is many. So project can have many employees, so max cardinality is not specified, but since minimum cardinality is one, a relationship is mandatory. And we have an example here on how employee assigned to specific projects. So we're going to talk about another important concept for entity relationship diagrams is degree of relationship. So um, a degree of relationship means the number of entity types that are part of a specific relationship. So if we are dealing with only one entity type, we have a unary degree. So that's when entity is related to itself. Um, we have binary relationship when we deal with relationship between two different entity types. And there's also an example of ternary relationships when three different entity types participate in relationship. We are not going to look at a lot of examples with ternary, but I'm going to show you one so you would just understand what is that. But ternary is not is beyond the scope of this course. All right, let's look at unary relationship examples. And just like we talked, it's unary when we have one entity related to the same related to another entity of the same type. So entities related to itself. We have binary with two different entity types and ternary with three different entity types. Um, so here's an example of cardinalities degree for unary relationship can be one to one, one to many. So one to one example is one person married to another person. One employee can manage multiple employees, so it's one to many. And teams. So here we have one team stands after another team. So it's also it's one-to-one relationship example for teams. So one-to-one and one-to-many. Let's look at a couple of examples of binary relationships. Similar to unary, we have one employee is assigned one parking spot, so it's one-to-one binary relationship between employee and a parking spot. We have product lines that contains multiple products, so it's one to many relationship between product and product line, and student can register for courses, so it's many students can register for many courses. It's many to many relationship. All right. So let's look at the examples and identify whether it's unary relationship or binary relationship. In company's employee management system, each employee may have one or more employees who report to them hierarchically. So, what kind of relationship is that? All right, so that is a unary relationship between employee and the other employees who manage them. So it's only one entity type participate in this relationship, so relationship is binary. Another example, in a bookstore system, each book can have one or more authors, and in each author can write one or more books. So how many entities participate in this relationship? Right, we have book and authors, and many books. Book can be written by many authors, and one author can write many books. So it's binary relationship, many to many. Each student can enroll in one or more classes, and each class can have multiple students enrolled. It's also binary relationship. Classes, students can register for classes. Now, here's an example of ternary relationships. So, this is a scenario where vendors ship different parts to different warehouses. And for those relationships, we record shipping mode and unit price. So we have many parts going to many warehouses, and we also need to record shipping mode. So the question is, what attribute is it an attribute on the relationship shipping mode, or it's an associative entity? I'm gonna pause for a second and let you think about it. All right. So that would be a relationship attribute because we don't have any uniqueness about this specific situation. So we don't have any specific meaning for this shipping mode. So that's why it's an attribute on the relationship. But if we for the conceptual data model, it can be attributed to the relationship. But once we get further down and work on logical design as part of the database creation, we probably will end up creating a separate entity for this case once we have more information and more details. So for the initial design, it can be either, it can be relationship attributes, but as we progress further, we probably will create an associative entity. Right, and here's an example of ternary relationship. I'm not going to spend much time here. You can read details on who does what in these relationships, and here's an example of business rules. I'm gonna skip this slide and go to another example. All right, so let's look at this scenario and try to identify the number of relationships, relationship types, and relationship cardinalities. It's a lot of information here, so I'm going to pause for a little bit and let you review this diagram, and then we're gonna discuss what is involved here. Right. So we have employee relationship degree here. So employee supervises multiple employees. Relationship cardinality on supervisors is minimum cardinality is going to be 0 and max. We don't know how many employees each employee can supervise, so it's undefined, but it's many. And the relationship is optional because minimum cardinality is 0. So another relationship we see here is supervised by. With the supervised by, we have minimum cardinality also 0, so relationship is optional. And maximum is not specified. So employee doesn't have to be supervised by another employee. So that's for supervised and supervised by relationship. We also have two different relationships between employee and department. So employee works in the department. We have minimum cardinality here is one is 1. So it's mandatory relationship. So employee department must have at least one employee in it. And there's no max cardinality for work things, so max cardinality is not specified. Now we have an employee that has workers. So employee that works in department, minimum cardinality is one, and max cardinality is one too. So one employee can only work in one department. There's also a relationship managers. So employee can manage department, and minimum cardinality is zero. So employee doesn't have a managed department, and max is not specified. But for the department side, department must be managed by at least one employee. So minimum cardinality is one and maximum is also. Um, so the question is, can department exist without employees? Um, no, because minimum cardinality on the employee side is one. So department must have at least one employee. Another example, so let's look at that. We have professor that um, teaches courses, and we have a specific example here. So it's called fixed lower limit constraint. So let's identify the number of relationship and relationship types and cardinalities for this example. So relationships, there's two types of relationship. Is qualified, that is between a professor and a course. So professor from the course, its minimum cardinality is one, relationship is mandatory. We don't know the max cardinality, and um, another relationship is on from the course to a professor. So we have cardinality, minimum cardinality two, which is a fixed lower constraint. Relationship is mandatory, but it's we haven't looked at the examples yet where minimum cardinality is more than one, and we don't know the maximum. So that describes is qualified relationship. We have another relationship schedule, which is implemented via associative entity, and it has minimum cardinality on the both side of schedule. Entity is zero, so it means that it's optional for both course and the professor to have a schedule. But in order for schedule to exist, it must have both professor and a course, and it must have only one professor and one course per schedule. So a relation minimum cardinality on both sides is one, and math cardinality is also one. So schedule is only for one occurrence of student and a course. All right. So question, is there a limit of courses that professor can be qualified for? So let's look at the professor and a course. Well, another question, is it a required course to be part of the schedule? No, the schedule is optional for both professor and the course. Now, can course exist without qualified professor? No, because course required at least two professors to teach this course. So the answer to this question is no. Now, we're getting closer to the end of this lecture, so I'm gonna talk a little bit about how to start working on entity relationship diagram. So those are basic steps, and that's what we'll be doing in the second part of the class. So how do we do that? First, we need to have a very detailed description of business rules. So we need to understand the business rules. We need to understand how business actually operates. So then we need to split those business rules into um, multiple groups. For the simplicity, because it's easier to work on the part of the business rule or business description, then it's easier to digest. It's simpler to understand. So then we developed entity relationship diagram for each of those groups, and later on, we combine all those small diagrams into one large diagram and identify the attributes and unique identifiers. And as the last step, we revise our final ERD. It's a very important step because sometimes we need to go, sometimes as we work on the different groups of requirements, we can miss something when we combine those requirements together. So reviewing your ERD is very good proof of the fact that your diagram is correct. All right. So let's look at the different diagram segments for small college. So first segment is professors work for department and schools. Then we have courses and departments. Then we have classes, personnel, academic planning, enrollment, students assigned to a different department, and professors assigned to students. So there's multiple segments. Again, how we develop them, we just slice and dice requirements and develop the diagram for each segment. And as a result, there is also segment 9 here. As a result, we get into something that looks like this. One diagram with multiple relationship with details. Again, iterative process of creating create diagram for small sections first, and then combine this diagram into one. And here is a detailed description of this diagram with details and rules on different relationships here represented in one large matrix. And that's all I have for you guys today. I next class is going to be going to be recorded how to create simple diagrams, and next week we will look at a couple more examples of more complicated diagrams. If you have any questions, let me know, reach out, and if not, I hope you have great rest of your day. Thank you.